Hi everyone, welcome back. In this video, we'll show how to draw the device and add the functionality to the PCell to create the geometry elements. And then we'll showcase how to view that geometry and the whole device layout in Python. And then finally, we'll show how to export the device into a GDS format. So first off, what we want to do is come into our class up here. We want to correct this misspelling. PCells C here should be capitalized. And we'll also comment out the trace template for now. This actually causes a problem at the current step of our example. So next what we want to do is, coming down to the layout side, we'll create the geometry objects. So in the class layout, we'll indent and we'll add a function. The function is called generate elements, and it will return the elements list. This list will contain all the geometries you will draw. Next, we'll create the actual geometry. So we'll do something called a lens plus equal. This means appending to the list. And then we can add in a I3 rectangle object. Sorry, let me figure out why it's not auto-completing. So it's capitalized rectangle. So the rectangle object will take in three things. It'll take in the layer, and we'll give it our device layer, self.device layer. It'll take in something called center, and this will be a coordinate 0, 0 for x and y. And then it'll take in a box size, so the span of the box, and we'll give it 1, 1 for now. And with this, we can try to view the object. So coming back to our standalone script area, we'll create a PCell object. We'll call it device Bragg, and this will equal the PCell we just made called Bragg straight. Next, inside that, we can create an object from it called device layout, and this will be calling that layout class that we see up here. This is device underscore Bragg. And with that, we can now use the functionalities of the layout. So the layout has a functionality called visualize, and we can set annotations to true. This will show any kind of labels or ports that we might have. And with that, we can run the script. If all goes well, we should see a Python window pop up that showcases our device. The device would just be a square. So annotations are spelled wrong. I think it's just annotation. I'll say annotate is what I wanted. So everything looks good. We have our quote-unquote waveguide here, centered around 0, 0 with a span of 1. So it all looks good. Now we can go back to our geometry section again and actually make it into a waveguide. So let's attach the values to our parameters now. So the center of the device should be at the number of periods multiplied by the period and then divided by 2. So we'll do self.period multiplied by self.period num, and it's divided by 2. We don't have to change the y value because we're not going to shift it up and down. And then next we need to give it the length, which will be the x value for the box size, and then the width, which will be the y value here. So the length of the box will be self.period multiplied by self.period times the number of them. So self.period num. And then we'll also give it self.waveguide width for the y value. And we'll actually want to minus a self.corrugation width here, self.dw. And the reasoning is because coming back to our definition here for corrugation width, we want to minus it here, and then when we draw the corrugation, we'll add in that amount back so that the waveguide width by definition is in the center of the corrugation. And with that, we can check our work. So we'll run it again. And we should see a very long rectangle. So it looks good. from a distance. We'll zoom in. So we have a long rectangle, looks good. But it's kind of hard to see. So what we can do next is, why don't we have it create a GDS? So we can call dev layout again. And this time there's a function called write GDS2. And all we have to pass to it is the file name that we want. So we'll call it example.gds. And then we'll comment out this line where we visualize, just because when we visualize, the box pops up and it waits for a user input. If we never close that box, that final line where we write to GDS doesn't execute, and we have to keep manually closing it. So now we see in our folder here that a example.gds is made. So I'll pull that up here. I'll double click it and load it. It's in my K layout. Taking quite a while. Let me drag it in. There. So we have our rectangle. So everything looks good. I'll close that extra K layout for now. So coming back to the code then. Next, why don't we add in some gratings now? So for the gratings, we'll want to create a loop. We want the loop to place a grating at every single suitable period, and these gratings will just be little rectangles. So we'll start up with a for loop for I in range. The range will start from 0 and it'll end at the number of periods. So that's how many gratings we have. So period num. Next, we'll want to place a rectangle each time. So we'll put lems plus equal i3.rectangle. In fact, why don't we copy it from down here? And then what we want to do is we want to make sure the spacing is correct here. So we'll delete this first so it's more visually easy to read. So we say everything is 0, 0. So for the center of each grating, we will want to, let me use a red pen. We will want to define the period, and then whatever the duty cycle is, which is this center point here, it can shift based on the duty cycle. We'll want to be half of that, and that will put us in the center of the actual box. So what we can do here is we'll do self.period is the full period, and then we'll multiply that by the duty cycle. So self.duty cycle, and then we'll divide by 2, and that should put us right in the middle. And then for the y value, we don't have to adjust it for now. It can stay 0. But we aren't done yet. This only works for the first grating. We have to tie this value to the I in the for loop. So as we go along, we want this I to increment, so it keeps placing gratings further and further down the device's length. So we'll also need to have adding I multiplied by self.period. So whichever iteration of I it's on will have a gap of a whole period. And that helps us create a proper loop that places all the objects. Next, we'll adjust the span of the box size. So this is more straightforward. Self.period multiplied by self.duty cycle. So that gives us the exact size of whatever amount of boxes we want to cover in that period. Then we want to add in a corrugation width, so self.corrugation width. And if you recall earlier, we minused it from the waveguide width, so we can add on to it self.waveguide width. And that puts us at where we are by definition, where the waveguide width is in the center, and then the corrugation is drawn upwards, and then the actual fishbone spine is lower. So with that, we can press execute script, and then we can check in our layout. So wait for the script to finish executing. Typed a duty cycle wrong. It should be duty cycle, not duty ISO. So there we go. And that should fix it. And we can go back to our layout viewer and we can click reload. And now you can see that we properly created our Bragg gratings. And that'll bring us to the end of this video. In the next video, we'll add in some ports, we'll add in the cladding, and then in the further videos, we'll do some refactoring to add in some of the booleans that we added. But for now, thanks for watching.